Hello everyone, welcome to today's class. This is Teacher Simon taking you through Cambridge International AS and A-Level Pure Mathematics 3, Paper 3-2 for October-November 2023, and this is part 2 for questions 7 to 11. Question 7 is coming from Trigonometry, Part A. By expressing 3 theta as 2 theta plus theta, prove the identity cos 3 theta is equal to 4 cos cubed theta minus 3 cos theta. Okay, so cos 3 theta is going to be equal to cos of 2 theta plus theta. Okay, now we know that cos of a plus b, when you check in the list of formulae, we have cos of a plus b, which is equal to cos a cos b, then minus sine a sine b. So that means here I will say cos 2 theta cos theta minus sine 2 theta sine theta. I'm going to express this one in terms of cosine of theta. Okay, we also have cos 2 theta, which is equal to 2 cos squared theta minus 1. So I can have 2 cos squared theta minus 1, then times the cosine of theta, then minus here sine 2 theta is 2 sine theta cos theta. All of this is given in the list of what? Formulae. So I will have 2 sine theta cos theta, then there is this sine theta here. Now when I open the brackets here, we shall get 2 cos cubed theta minus cos theta, and then we can have, let me write cos 2 cos of theta, then there is sine squared theta. But sine squared theta, I'm also supposed to put it in terms of cosine, such that because you see what we are supposed to prove, there is no sine in it. So minus cosine of theta, then minus, this will be 2 cos of theta. Expressing sine squared theta in terms of cos, we shall have 1 minus cos squared theta here. So that means here we shall have 2 cos cubed theta minus the cosine of theta. Then here when you open the brackets, we shall get 2 cosine of theta, then plus 2 cos cubed theta. Now this is 2 cos cubed theta plus 2 cos cubed theta. That one will give us a 4 cos cubed theta. And then minus cos theta minus 2 theta, that will be minus 3 cosine of theta. And that is what we are told to show here, or to prove. Part B, hence solve the equation, this one here, for theta ranging from 0 to 180. Now, I will have 4 cos cubed theta, this one here, then minus 3 cos theta, then plus, this is cos theta, cos 2 theta, which is equal to cos squared theta. Now this is 4 cos cubed theta minus 3 cos of theta, plus, I can break this one down in terms of cosine of theta, which is 2 cos squared theta, then minus 1. Okay, I can even bring this cos squared theta this side, then I have a 0. So 4 cos cubed theta minus 3 cosine of theta. Then when we open here, that is plus 2 cos cubed theta minus cos theta, minus cos squared theta, which is equal to 0. So this is 6 cos cubed theta, and then minus cos squared theta, this one here, and then we go to the cosine of theta. We have this and this, so that will be minus 4 cosine of theta, which is equal to 0. But cosine of theta is actually common. I can pull it outside, then I have 6 cos squared theta, then minus cosine of theta, then minus 4. Okay, so that means I will have cosine of theta equal to 0, and then theta becomes the arc cos of 0. This one gives us 90 degrees, 270, like that. Then this other one here cannot be factorized. So what I can do is to show the examiner that I've solved the equation. So it is a quadratic in cos of theta. Okay, so you substitute in the quadratic formula, at least put one step, and you say that cosine of theta is equal to minus b, then plus or minus to the root of b squared, then minus 4a, and then c. Okay, then you divide by 2a. Okay, so cosine of theta is going to be equal to, this one will be a positive 1, then plus or minus, this is 4 times 6, 24, 24 times 4, that is 96. So plus this one that comes from here, that is 97. Remember, this is minus 4, and then this is a minus. The negative times the negative, that's a positive. So this is root of 97, then out of 12. So theta is therefore going to be the arc cos of 1 plus root of 97 over 12, or theta can be equivalent to the arc cos of 1 minus root of 97 over 12. So we have these 4 quadrants where we are supposed to pick the angles from. I have 0 degrees here, this is 90 degrees, this is 180, this is 270 degrees, this is 360. Then if this is an angle theta, and then this one is also theta, protrude this one here, opposite angles are equal, same to this one here. To get an angle here, it will be 180 plus theta. To get an angle here in the second quadrant, it is theta, 180 minus theta, and then this one will be 360 minus theta. That is when you move like this up to here. And moving clockwise, I mean anti-clockwise, the angles are positive, but when you move clockwise, the angles are negative. Now let's check this one. The calculator must be in degrees because the domain given was in degrees. So arc cos of 1 plus root of 97, then we divide by 12. This one is 23.3. So here it is 23.3 degrees. Now this one is, this part here is positive, so I'm supposed to pick angles from the first quadrant and then fourth quadrant. So the next angle would be 360 minus that 23. I think it is 25. It is 25.3. So minus that 25.3. Okay. But since our domain here, the angles must range from 0 to 180, I will not get the other second angle. Okay. 360 minus what? The 0. Okay. So I will just get this one here. Then this other one here, I will just come here and then change this to a negative. It is 137.5. Theta is equal to 137.5. This is an acute angle, and it comes from, this is an obtuse angle. It comes from the second quadrant where cosine is negative. So that means this thing is negative. So we are supposed to pick angles from the second quadrant here and also the third quadrant here. But since we are moving from 0 to 180, I don't need this other angle here because it is already bigger than 180. So my two answers are these ones, this one here and this one here. Question 8. It is given that 2 plus 3ai out of a plus 2i is equal to lambda 2 minus I, where a and lambda are real constants. Show that 3a squared plus 4a minus 4 is equal to 0. Alright, we can begin by cross multiplying. This is a plus 2i, which is equal to lambda, then 2 minus I. So when I cross multiply, I'll have 2 plus 3a of I, which is equal to lambda minus 2 minus I, then a plus 2i. Now when we open up the brackets, this is 2 plus 3a of I. I can first leave maybe the lambda, so 2 times a, that one will give us 2a, then 2 times this one, that one will give us 4i, then negative I times a, that is minus ai, then negative I times 2i, that one will give us minus 2i squared, okay? But we know that I squared is a negative 1, so that one will make it a positive 2. So we shall have a positive 2 here. Now, opening the brackets again, so this is 2 plus 3ai. I can separate the real from the imaginary ones. So this is 2a, then plus 2. We shall have 2a plus 2, then multiply it with the lambda, and then the imaginary here is 4 minus a, okay, times lambda, and then there is I, okay. Then complex numbers are said to be equal if the real roots are equal, the real part is equal, the real parts are equal, and the imaginary parts are equal. So equating real and imaginary parts. So this one here is 2, the real part, and then the real this way is that. So we shall equate to 2a plus 2 lambda. I can make lambda the subject of the formula here, okay. It is going to be 2 out of 2a plus 2. I can actually divide all through by 2. This one can be 1 over a plus 1, okay, because the 2 is common everywhere, so that is what we have. Then let's go to the imaginary part. 3a is equal to 4 minus a of lambda. And so we have 3a here, which is equal to 4 minus a, and our lambda is this one here. So that means I will have this one out of a plus 1. So when we cross multiply, okay, when we cross multiply, we shall have 3a times a plus 1, which is equal to 4 minus a. So this will be 3a squared when we open the brackets, plus 3a, bring everything this way, minus 4 plus a, which is equal to 0. So this becomes 3a squared, then plus 4a minus 4, which is equal to 0. And this is what we are told to prove. 3a squared plus 4a minus 4 is equal to 0. Part B. Hence find the possible values of a and the corresponding values of lambda. So we solve we solve this equation that we have gotten, 3a squared, then plus 4a minus 4, which is equal to 0. So I can factorize this. You can get your calculator and you do that very fast. We go to equation. Equation is 5, then quadratic is 3. Our a is 3. Then our b is 4. Our c is negative 4. So this one gives us 2 over 3 and then negative 2. A is equal to 2 over 3. And then this one is equal to negative 2. Always leave space. You see that I've always left the space because I have to show the examiner that I've solved the equation. So I have to show that I have factorized, okay? Or you can use the formula, the quadratic formula, but don't just write these answers. You lose a mark. So cross multiply. This one will give us 3a. Now when you bring this one back here, it will be minus 2. That is the factor from which this root comes, okay? Then bring this one here. It will be a plus 2, which is equal to 0. Now, they said find the possible values of a. Those are the two. This one here, and then this one here, okay? And the corresponding values of lambda. Now, for a, which is equal to 2 out of 3, remember lambda is equal to 1 out of a plus 1. We saw it when we were solving before. So that means lambda here is going to be 1 over, this is 2 over 3, then plus 1. So what will be lambda here? Then the other one is a is equal to negative 2. That means lambda is going to be equal to 1 over negative 2 plus 1. Of course, this one is going to be a negative 1. Okay, because you have 1 over negative 1 down. Now, what is this one here? 1 divided by 1 plus 2 out of 3. This is 3 over 5. 3 out of 5. That is that. Question 9. The diagram shows the curve y is equal to sine x cos 2x for 0 less than x less than pi and a maximum point M where x is equal to a. The shaded region between the curve and the x-axis is denoted by r, but find the value of a correct to 2 decimal places. Okay, now since a is a stationary point, I mean M is a stationary point, we shall differentiate this and then equate to 0. Okay, then we solve accordingly. But this is a product of two functions, so we are going to use the product rule. Okay, where you keep one constant, you differentiate the other. So we shall keep our dy dx is going to be keep this sine x constant, then differentiate cosine of 2x. Then from there add, we can add and we say cos 2x is now constant. Then we differentiate with respect to x, the sine x. Okay, and that is that. So when we differentiate here, we shall have sine of x times, this is cos 2x. When you differentiate cos, you get a negative sign. Okay, we get negative sine of 2x, but then we have to enter here and we differentiate that angle, so we get a 2, then we multiply it all through. So that's why I'm writing there negative 2 sine 2x. Then plus, when you differentiate a sine, you get a positive cosine of x. Okay, now for x which is equal to a, here the x coordinate here is a. So when x is equal to that a, this M here becomes the stationary point. So therefore, dy dx has to be equal to 0. Dy dx is equal to 0. So wherever there is x, I'm going to put a. So this will be negative 2 sine a sine 2a, then plus cos 2a cos a, then is equal to 0. Okay, now I'm going to use the expressions for double angles to solve this one. So we have negative 2 sine of a, then times this sine 2a is 2 sine a cos a, and then this cos 2a, I can put it in terms of cosine or in terms of sine. Okay, so I can have maybe in terms of cosine, so 2 cos squared a, then minus 1, and then cos of a. This one is going to be equal to 0. So here we have negative 4 sine squared a cosine of a, and then plus cos. In fact, I'm going to leave this one. This is cos of a, then 2 cos squared a minus 1, which is equal to 0. Now cos a is common here and here. So what I can do is to first factorize it out. Then here we get negative 4 sine squared a, then plus 2 cos squared a minus 1, which is equal to 0. But I can express either cos squared in terms of sine squared or sine squared in terms of cosine squared. So whichever you want, that is what you can do there. Now cosine of a is going to be equal to, let me express this one in terms of cosine, negative 4 into 1 minus cosine squared of a, then plus 2 cos squared a minus 1, which is equal to 0. Then this is cosine of a, this will be negative 4, then this will be a positive 4. Okay, in fact, let me just do it all at once. So plus 4 cos squared a, then plus 2 cos squared a minus 1, which is equal to 0. So meaning your cos of a here outside, inside here we are going to have 4 plus 2, that is 6 cos squared of a. Okay, minus 4 minus 1, that will be minus 5, which is equal to 0. So we can get cos a, we equate it to 0, then a becomes the arc cos of 0. The domain is given in radians, so a can be equal to 90, which is pi over 2, or 270, which is 3 pi over 2. But then this one here, 6 cos squared a, then minus 5 when equated to 0, cosine of a is going to be 5 over 6, the cos squared. So cos of a is going to be the plus or minus the square root of 5 over 6. Now I will take the positive because you can see where m is. It must be an angle that is far. So if this is 180, then in the middle here, that is where we can get the 108, I mean the 90, which is pi over 2. So this angle here is in the first quadrant, and in the first quadrant, we have angles, all of them, the trigonometric expressions are positive. So meaning, and I will not take, do you see that I've gotten an answer here, pi over 2? Now pi over 2, since I've shown you here that this is a half of this, so then it is for the next turning point. Okay, the pi over 2 is here. So we have to look out for another answer, okay, that corresponds to that m. And that one must come from here, where we have our a, cosine of a, which is equal to plus or minus root of 5 over 6. So I'm going to take a, being equal to the arc cosine of root of 5/6. Okay, so putting this in the calculator, remember it has to be in radians. What is our A to 3 significant figures? We change the calculator to radians, then shift cosine, then we have the square root of 5/6. This one gives us 0.421. 0.421. That is 3. That is in radians, and to 3 significant what? Figures. So that is that. Part B, find the exact area of the region R, giving your answer in the simplified form. Now, the shaded area here, R, we have to get the limits. It is cutting x-axis at this point here, which we don't know, and this point here. So we need to first find these limits, okay? And on x-axis, you know that y is equal to what? 0. So therefore, I will say here on x-axis, y is equal to 0. So sine of x, then cosine of 2x, because that is how y will be equal to 0. So sine of x is equal to 0. Of course, x here is going to be the arc sine of 0, which is going to give you 0, 180, 260, 360. Then how about this cos 2x equal to 0? So meaning 2x is going to be the arc cosine of 0. Then x will be equal to a half of what we get from here. So this is 90, okay? This has to be 90, and 270, so 3 pi over 2. These ones, they give you their cosine as a 0. So meaning x here can be equal to pi over 4 or 3 pi over 4, okay? Now, when we go back and check the graph, I've told you that this one is the pi over 2, okay? There's an angle here which has to be less than the pi over 2, okay? And this angle here has to be greater than this one that we have gotten here, 0.421. So when I get my calculator and we look out for, we have pi over 4, we have gotten the other side, so shift pi, then here we divide it by 4. The answer we get here is 0.785. It is bigger than the 0.421, okay? But then when we get 3 pi, okay, when we get 3 pi over 4, this one here is 2.356. It is bigger than this 0. The value of A. It is bigger than the 0.421, okay? How about pi over 2? Is it bigger than pi over 2? So shift, then I get the pi, divide by 2. This one is 1.57. The other one is 2.356. So that means that other answer we have gotten as 3 pi over 4 is this other limit here. This other limit, because it is bigger than this pi over 2. Okay, so that is what we are having there. So meaning that our shaded area is going to be equal to the integral. Now from this to that, those are our values. So from pi over 4 to 3 pi over 4, and we are having here sine x, then the cosine of 2x with respect to x. And since this area is below the x-axis, okay, it just shows that when you just integrate directly, it is going to give you a negative value, but area cannot be a negative, okay? So that means I can put the modular signs there to make it, the result be positive, okay? So that is that. This is a product of two functions where we are supposed to use integration by parts, but all of these a trigonometric function, so you cannot use integration by parts here. Now I can split this one. Sine x cosine of 2x is equal to sine of x. Then inside here I can have 1 minus 2 sine squared of x, which actually gives us, when you open the brackets, sine x, then minus 2 sine cubed x. Okay, now that means that our area here is going to be equal to this one. Let me first pull it off. Our area is going to be equal to the integral from pi over 4 to 3 pi over 4. We shall have sine of x and then minus 2 sine cubed of x, like that, then with respect to x. Okay, now in integration, if you find the odd power of the sine, or odd power of cosine, or the power of tan, you split them, okay, using the Pythagorean identity. Okay, so what are we going to have here? Using the Pythagorean identity, this sine cubed x is the same as sine of x into sine squared x. Are we there? Then the sine squared x, I will express it in terms of the cosine. So 1 minus cos squared of x. If we have the even power of sine or cosine, we use the double angle of cosine. Okay, then for all the powers, we use the Pythagorean identity. So the sine squared is equal to 1 minus cos squared. Okay, now from here we can actually let now substituting here, I can come back here and substitute. Let me just have something like this, and then we have, when I integrate sine, we get a positive, in fact we get a negative cosine, so that's a negative cosine of x, then minus, of course this one I will put a 2 here, and then I can integrate. Remember, it is this one here, so I can have sine x here into 1 minus the cosine squared of x. Okay, with respect to x, let me just put my limits here. Pi over 4, 3 pi over 4, and then pi over 4 here. Now I can let my u, this is integration by like substitution, so I can let my u to be equal to the cosine of x. When I let it to be the cosine of x and I differentiate this one with respect to x, okay, we shall get negative sine of x. So meaning dx here is going to be equal to negative du over the sine of x. So when I put this one here, this sine is going to disappear. It will cancel with this one here. You see that? So that means here we shall have negative cosine of x, then minus 2, and then integrate. This is sine of x here, and then here we'll have 1 minus u squared, since I said let cos be the u. Then from there, dx is negative du over sine of x. Okay, so like that, put our limits, then pi over 4, then we shall have, this is cosine, negative cosine of x minus, this one has disappeared, we have to the integral of, actually I can say plus, this negative, I take it out here, it multiplies with that. Then we shall have 1 minus u squared with respect to u. Okay, these limits that I'm having up here, they are for x, they are not for u. So I have to put back my x. after integrating this with respect to what? To u. So minus cosine of x, then plus 2. This will be u, then minus 2, then u cubed over 3. Okay, when you integrate this, you get u cubed over 3. Then I've multiplied it with the 2. You see that? So like that. Then bring back that we let u to be the cosine. So we shall have negative cosine of x, then plus 2 cosine of x, then minus 2 cos cubed x over 3. Now I can put the limits there. Okay, now when we proceed from here, of course 2 cos x minus cos x, here we shall get a positive cosine of x. Okay, then minus 2 over 3 cos cubed x. Okay, then 3 pi over 4. This is pi here over 4. Remember, this one all is in the modulus. So now put the limits. Cos 3 pi over 4 minus 2 over 3 cos 3 pi over 4. But then after we shall cube it. Then minus. Here we shall have cos pi over 4. Then minus 2 over 3. Then the cosine of pi over 4. Then after that, we cube it. Then under the modulus. So cos of 3 pi over 4, what do we get? Cosine of 3 pi over 4. So this one gives us negative root 2 over 2. Okay? Negative root 2 over 2. But there is somewhere where we are supposed to cube this one. So suppose I cube this. When I cube it, the negative root 2 over 2, we shall get negative root 2 over 4. Okay. Now I'll come here and I write negative root 2 over 4. Okay. Then we have this one here. It is minus 2 over 3 times, it gave us negative root 2 over 4. Then we subtract. This one here is root 2 over 2. So root 2 over 2. Okay. Then minus 2 over 3. What is root 2 over 2 cubed? Root 2 over 2 cubed. That is root 2 times root 2 times root 2. Then over 8. This one gives us a 2. You see? So 2 cancels this one to a 4. So it is root 2. It has to be root 2 over 4. Okay, so we shall have root 2 over 4. Answer? Root 2 over 4. Like that in the modulus. Now this is negative root 2 over 4. When you multiply here, it becomes a positive. So this one will cancel this. Then we have a 2 there. And that one becomes positive root 2 over 6. Because the 3 here we multiply with the 2 that comes from the simplification. Then minus. This is root 2 over 2. Then plus. Then again, this one here. 2 goes in here too. So we shall have a 6 here. And because of this minus, then it will become a positive root 2 over 6. Okay? Root 2 over 6. Then simplifying all of this, what do we get? I can put everything in the calculator and it gives me the answer. Actually, this one here is supposed to be root 2 over 2. Pardon me here. This is root 2 over 2. It is the one that we cubed to get negative root 2 over 4. So which is here. Okay, now simplifying all of this, what do we get? We have negative root of 2, then out of 2, then plus root of 2. In fact, everywhere we are seeing root 2. So let me just factorize it out. So we have negative 1 over 2, the coefficient of the first one, then plus 1 out of 6, then minus 1 out of 2, then plus 1 out of 6. So it gives me negative 2 over 3. Okay, remember we have the modulus. Do you see that the answer we get is a negative? So we have the negative 2 over 3. Remember root 2 was common. So this whole thing now becomes 2 root 2 over 3. Remember they said the answer must be exact. Okay, exact. So no decimal places. That is that. It has been a long method. However, since they never specified what we use here, you can also use what we call the factor formula. It is not so common in the Cambridge books, but this is what we are going to use here. So let me put it here. The factor formula or formulae. You can check it out on the internet. You will see all of them. There are very many, but I'm just going to use one, okay, for this case. And what do we have here? The one that we are having here is the integral. We have sine and cos 2x. Okay, we have sine of a plus sine of b. We get 2 sine of a plus b over 2, the big angle, and then cosine of a minus b over 2. Okay, then sine of a minus minus sine of b. Now we shall get 2 cosine of a plus b over 2, and then sine of a minus b over 2. Okay, there are also others for cosine, where we have cosine of a plus cosine of a. You get 2 cos. So 2 cos of a plus b over 2, then cos of a minus b over 2. Okay, then we have cosine of a minus cosine of a. This one is equal to negative 2 sine of a plus b over 2, and then sine of a minus b over 2. Okay, now in our integration here, we are having sine then cosine, but the big angle is on the cosine. Okay, so if the big angle is on the cosine, let's go back to our factor formula. Where do we find sine and cos? And cos is the one with the big angle. Cos is the one with the big angle. Sine and cosine, they are here and here. So the big angle comes from the plus. Okay, so that means this is the one we are going to use here. So 2 cosine of a plus b over 2, then sine of a minus b over 2. I'm actually going to divide all through by these 2, because what we are integrating, there is no 2. So this one is going to be a half of sine a minus sine b. So how do you get a and b? You just get this one plus this. Okay, if I get a plus b over 2, then plus a minus b over 2, the LCM is the same. So you have a plus b plus a minus b over 2. So b goes, we shall have 2a then over 2, which is a. So do you see that to get the a here, I will just get my angles and I add them. You see that? Then how about to get the B? I just subtract them. So A plus B, then minus the A minus B over 2. When you open the brackets here, it is A plus B minus A plus B over 2. So do you see that A disappears? Then you get 2B out of 2. Okay? Which is B. So therefore, my sine of x cos 2 of x, I can actually shift this such that it resembles what we are having there. I can shift the sine. You write the part with the big angle first. Sine of x then is going to be equal to a half sine of, when you add these to 2x plus x, what do you get? You get 3 of x, and then this is sine of 2x 2x minus x, you will get an x, so this will be x here. Okay, we shall get an x here, just like that. Now this one becomes very easy to integrate. When you use this factor formula, you can actually look out for many examples on the internet or in the books, and then you get familiar with this. It becomes very easy to integrate. I'm not supposed to show all of this when I'm doing. I just begin from here, that this one is equal to that, then I go for the integration. So our shaded area, remember we are integrating from pi over 4 to 3 pi over 4, and we are having sine x, then the cosine of 2x with respect to x. Now I will have a half outside here, then pi over 4, 3 pi over 4, then put this sine 3 of x, then minus this one here, the sine of x dx. Now when we integrate this one, when you integrate sine, you get a negative cosine. So negative cos 3 of x, then of course we shall divide by the 3, then minus, when you integrate a sine, you get a negative cos, so negative cosine of x. Of course we are dividing by 1 because when you differentiate that angle x, you get that 1 there. And then we have 3 pi over 4, and then pi over 4 here. Now remember, our shaded region is below the t-axis, I mean the x-axis. So we shall have our modulus, this is a half. Now put the limits. You have negative cosine of 3 times 3 pi over 4, then over 3. This will be a plus. Cos of 3 pi over 4, like that. Then we subtract, substitute the lower limit, negative 3, I mean cos of 3 pi over 4, then there is a 3 down, and then plus cosine of pi over 4. Okay, like that in the modulus. So we have a half here, then the big bracket. What do we have here? I will have cosine of 9 pi over 4. So this one will give me that, then divide by 3. So that will be root 2 over 6. I'll write negative root 2 over 6. Okay, then plus cos of 3 pi over 4, cos of 3 pi over 4, that is negative root 2 over 2. So negative root 2 over 2, and then when we shall get minus, so this one we have seen it is negative root 2 over 2, so it multiplies with that negative, it becomes a positive. Then the positive finds the negative here, so it is a minus. Then the negative root 2 over 2, so negative root 2 over 2 minus negative root 2 over 2, so negative root 2 over 2 minus negative root 2 over 2, so negative root 2 over 2 minus 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 negative root 2 root 2. It's a minus root 2 over 2, but there is a 3 down, so it is a 6 over 6. Okay, then cos of pi over 4 is root 2 over 2, so that is minus root 2 over 2. Now we simplify this one here. So root 2 is again common, so I'll have negative 1 over 6, then minus 1 over 2, then minus 1 over 6, and then minus 1 over 2. So we get negative 4 over 3. So modulus, this is a half, times this is negative 4 root 2 over 3. Okay, then here 2 goes into the 4 2 times, right? So you get 2 root of 2 over 3 negative. But now of course the modulus makes this one positive, so you get 2 over 3 root of 2. Same answer. I think it is the same answer that we got here. You see, 2 root 2 over 3, and also here we have gotten 2 root 2 over 3. So factor formula, if you master it, it can simplify your work. You just begin from here and you integrate. You see the working? That is that. Question 10, the equations of the lines L and M are given by this. Then where C is a positive constant, it is given that the angle between L and M is 6 to find the value of C. So we are going to use the scalar product. Using the scalar product, the directional vector of L, dot it with the directional vector of M. Then this one is equal to the modulus of the directional vector of L times the modulus of the directional vector of M, then cosine of theta. Okay, so this is 1, 1, 2 for L, and then dot it with negative 2 for C. Okay, then after that we come this way. It is going to be 1 squared plus 1 squared plus 2 squared, then times the square root of negative 2 squared, then plus 4 squared plus C squared. Then cosine, the angle is already given as cos theta, 60. So when I multiply here, I will get negative 2, then plus the 4, then plus the 2c. This way, this is 4 plus 1 plus 1, that will be 6. So this will be root of 6, then times the square root of this is 4 plus the 16, that is 20. So that means here we shall have 20 plus c squared, and cosine of 60 is a half. Okay, then I can actually, this one will give me a 2. Then I can cross multiply. I can multiply everywhere by what? By 2. When I multiply by 2, just to eliminate the denominator. Okay, so this one gives me a 2, then plus the 2c. Now when I multiply by 2, that one will give me 4 plus 4c. Then here we have root of 6 times root of 20 plus c squared. Then I can square both sides. Square both sides. So I will have 4 plus 4c squared, then plus root of 6. It's not a plus, it's an equal sign. So we are going to have this is equal to this one squared, then times also this one here squared. So here we shall get 16, then 2 times 4, that is 8 times 4, 32. So we shall have plus 32c, then plus square the 4c. That one will give you a 16c squared. Then here you will get a 6, then into 20 plus c squared. Then opening the brackets, we can have, this is 16c squared plus the 32c, okay, then plus the 16. I can bring everything this way, okay, so we can have minus 120, then minus 6c squared, which is equal to 0. So 16 minus 6, that one gives us a 10. So 10c squared, 32c, yeah, it is just 32c. So plus 32c, and then 16 minus 120, that one will be 104. So negative 104, which is equal to 0. If I divide all through by 2, I can get a 5 here. Then here 8, 16. And then here we can get 52. Yes, 52, which is equal to 0. Now, this is a quadratic which can be factorized, so let's check it out. So 5, then 3, then we can have 5, 16, then minus 52. So that is a 2 and negative 26 over 5. So C is equal to 2. And then also C is equal to negative 26 over 5. Remember, you have to show how you solve the quadratic. So C minus 2, when you bring this one back, and then also cross multiply here, so you will have your 5C, then plus the 26. Okay, so they said that find the value of C. C is a positive constant, so pick the positive value, and then you conclude. You don't just leave your answers there. You conclude C is equal to 2 because it is positive. Okay, but be sure that the length of the perpendicular from this point here to L is root of 11. So I can have my line here, so that is the line L. Then there is this perpendicular to it, which is from point A. Let's say this point is A. It is given as 6, negative 3, and then 6. Okay, so it is going to meet, there is a point here on this line, okay, that meets with this A at 90 degrees. Okay, so let me make that point be P. But since this P lies on the line L, then it must satisfy the equation of the line L. Okay, so when I come back here, the equation of the line L is here. So we use the parametric equation 3 plus lambda, then negative 2 plus lambda, then 1 plus 2 lambda. Okay, that is what we are going to have there. Now, that means the x coordinate of P is going to be 3 plus lambda. The y coordinate is negative 2 plus lambda. The z coordinate is going to be 1 plus 2 lambda. Okay, now we need to get AP. There is a directional vector of L. So this vector AP is perpendicular to this directional vector of L. Then we use the dot product for perpendicular vectors, which is equal to what? 0. Okay, so what is our AP? AP is going to be OP minus OA. You just get the last minus the first. Why? Because if I have point P here, I have point A here. This is the origin where they are beginning from. You have O to A, you have O to P. So if you want to go to P, you say AO plus OP. But AO is the negative of OA. You see that? Then this one is positive. So since this one is a minus, it's just a matter of getting the last one minus the first one. As simple as that. Okay. Now, what are we going to have here? Our OP is this 3 plus lambda, then negative 2 plus lambda, and then 1 plus 2 lambda. So when I subtract OA, it is 6, negative 3, and then 6. So 3 minus 6, what do we get? We get negative 3 here, then plus the lambda. And then negative 2 minus 3, that is negative 2 plus 3, which gives us a 1. So we shall have 1, then plus the lambda. Then 1 minus 6, that one will give us a negative 5. So this is negative 5 plus 2 lambda. You see that? Now, let's dot the 2. AP dotted with the directional vector of L should give us a 0 because they are perpendicular vectors. So this is negative 3 plus lambda, 1 plus lambda, and then negative 5 plus 2 lambda. The directional vector of L is 1, 1, 2. So I equate this to 0. So this times this times that, and this times that. So what do we get? We have negative 3 plus lambda, then plus 1 plus lambda. And then when you get 2 times this, you will get a negative 10. Okay, negative 10, then plus 4 lambda. So this one is equal to 0. This is 4 lambda plus lambda plus lambda. That is 6 lambda. Okay, 6 of lambda. And then negative 3 minus 10, that will be negative 13. Then when we add a 1, that will be negative 12. Negative 12, which is equal to 0. So meaning lambda is going to be equal to 12 divided by 6, which is actually a 2. Now we need the length of AP. So let us find the vector. Now AP. So what is the vector AP? Substitute here. You will have negative 3 plus 2, then 1 plus 2, and then negative 5 plus 2 times 2, that is a 4. So this one gives us negative 1, then 3, and what is this one here? Negative 1. So what is the length of this perpendicular here? It's the square root of negative 1 squared plus 3 squared, then plus negative 1 squared. Now when you square 1, that is this is a 1, this is a 9, that is 10, then plus 1, that is 11. And this gives us the answer they told us to show. As simple as that. Question 11. The variables x and y satisfy the differential equation. This one here, it is given that x is equal to 1 when y is equal to 1. Solve the differential equation to obtain an expression for y in terms of x. So the first thing to do is to separate the variables. Okay, separating variables. The marks are 8, so that means there is some good methods of integration here. So separating variables, I can first take y away and I take it that side. We can have x squared dy dx, which is equal to negative y squared minus y. Okay, in fact I can write this one as factorize out the negative y, then you have y plus 1. You see, now you can switch these ones, you cross multiply, in other words. So that means we shall have negative dy, then over y, x, not x, it is y plus 1. In other words, I've divided all through this one here. Okay, and then after that I divide through by x squared, having put the dx here. So x squared is going to be here. Okay, then after that, now we can integrate. Okay, integrating both sides, we have that. But now, do you realize that this is a product of linear factors? So we have to therefore reduce this one here into partial fractions. This is why they give you these many marks, because there is that other method. Okay, now we are going to have negative 1 over y into y plus 1, which is going to be a over y, then plus b over y plus 1. Cross multiply these ones, we shall have a times the y plus 1, then b times y, then this one will be equal to the negative 1 that is here. So by letting y to be equal to 0, if y is equal to 0, remember we are supposed to look out for the values of y that terminate one of the terms here, and then we remain with the other that gives us the values that we are looking for. So if y is equal to 0, this one will go. Then we shall have here our a. Okay, now that a is going to be equal to the negative 1, which is this side. As simple as that. Then if y is actually equal to negative 1, that means this one will go. So we shall have negative b, which is equal to negative 1, meaning b shall be equal to positive 1. So this simply implies that we are integrating what we had here, now we have here. So a is a negative 1, okay, out of y, then plus b, which is a 1 out of y plus 1. Then this one with respect to y, and then we are integrating this one. I can write it as x power negative 2 with respect to x. Then from there, we can have, this is negative natural log of y, because when you differentiate y, you get 1. So what should I do to this one to make it a negative 1? You will multiply by negative 1. So this operation is the one you put on the natural log here. Okay, so we have negative natural log of y, and then here when you differentiate this, you get that one that is there. So it will be a plus natural log of y plus 1, and then this way increase the power by 1, so it will be negative 1, and then you divide through by that power. So you have x power negative 1 over negative 1, which can be written as negative 1 out of x. Okay, because we don't write the denominator, the negatives in the denominator, and using rules of indices, this one can go down, so that's why it is this. So I'm going to write negative 1 over x, negative 1 over x. Then I can put the constant of an arbitrary constant of integration. You can put it this side or this other side, okay? But when you look at both sides and I put a plus c, then even this way I put a plus c, another constant, not c. These two are going to subtract each other, and then we get one constant. So that's why we choose to put the constant on one side, okay? Now, we are given the initial conditions, x is equal to 1 and y is equal to 1. This is the general solution. Now, how about the particular solution? That is when we get the value of c. X is equal to 1, y is equal to 1. So negative natural log of 1, then plus natural log of 2. This one is equal to negative 1 here plus c. So meaning c shall be equal to, take this one this side, it will be a positive 1, then plus the natural log of 2, because natural log of 1 is a 0. Okay, so meaning when we fall back here, now to get our particular solution, we have negative natural log of y plus natural log of y plus 1. Then this one is equivalent to negative 1 over x, and then our c is 1 plus the natural log of 2. And they want us to obtain an expression of y in terms of x. So I will come here and then I put the logarithms together. Here I'll have natural log of y plus 1, then divide by y. Because the subtraction of logarithms, we divide those powers. Okay, then this one is equal to negative 1 over x, and then plus 1 plus natural log of 2. I can bring this one this side. Okay, so I will have natural log of y plus 1 over y, then minus natural log of 2, which is equal to 1 minus 1 over x. Okay, then from there, of course, I can divide the powers. So I will have natural log of y plus 1 over y, then you divide by 2. Okay, now this one will somersault. You have 1 over y, y plus 1 over y, then times the reciprocal of this one, which is 1 over 2. So this 2 will multiply with that y. So altogether, I can just write in the denominator 2y here, just like that. Then is equal to 1 minus 1 over x. Now, we need to take away this natural log, so that means this is y plus 1 over 2y, which is equal to e to the power of 1 minus 1 over x. You see that? Then after that, we can cross multiply, right? So if we cross multiply, we need to make y the subject of the formula. So we shall get y plus 1, which is equal to 2y, then e to the power of 1 minus 1 over x. Okay, So remember, we have y plus 1, which is equivalent to, we have y plus 1, which is equivalent to 2y, then e to the power of 1 minus 1 over x, right? Then we need to put together y on one side, okay? So we can have 1 is equal to 2y e to the power of 1 minus 1 over x, then minus the y. Then from there, we can factorize y. So this will be 2e to the power of 1 minus 1 over x, and then minus 1. So making y the subject, y will be 1 out of 2e to the power of 1 minus 1 over x, then minus 1. So this is what I've gotten here. Now, there are many ways you can express this one here, okay? They never told us to put it in whichever format, but just y in terms of x. That is what we have. And then they're saying that state what happens to the value of y when x tends to infinity. Give your answer in the exact form. Now, as x tends to infinity, what we are going to have here, let me just write this as x approaches infinity, as it becomes a very big value. We know that 1 over 0 is undefined, okay? That means when we cross multiply, it will be 1 over infinity is going to be 0, okay? So you come to this one here, x has become infinity. It's a very big value. So that means you have 1 over that infinity, which goes to 0. So this whole thing will go to a 0, and then we shall have 1 over e to the power of 1, then minus this one here. So that will be the value of y. So I will conclude like this, and I say 1 over x shall tend to 0. So therefore, y has to be equal to 1 over 2e power 1. I don't need to write that power, then minus 1. So that will be the value of y. So this has been it for this paper. Thank you so much for watching. May God bless you. If you find the videos very helpful to you, kindly like, share, and even subscribe. See you in the next videos.